Students, this is a help video for the Circle Half Chapter quiz. This is going to work you through a portion of each of the questions. To graph a line, the first thing you want to do is get it in y equals mx plus b form. So we want to get y by itself. So we have 5x plus 2y equals 4. Your goal is to get y by itself. So the first thing we want to do is get rid of the 5x. So we're going to minus 5x both sides. We have 2y equals, the x can't be subtracted from something that doesn't have an x, so we have negative 5x plus 4. And to get y by itself, we divide by 2, and when you have to divide, you divide everything out. So we get y equals negative 5 over 2x plus 2. Right underneath, you're going to write the equation for slope. Y equals mx plus b. Your slope is right here, and it's negative. And your b is right here, it's positive 2. You want to graph those two on the graph and string a line through it. It says down below, in the circle below, EG is a diameter. Stop. First thing you want to do is trace and stretch that diameter. There's the diameter there. It says it's EG, so we're going to trace it and stretch. Keep in mind that that means you have 180 going two different directions. 180 going this way, and you have 180 going this way. We're told F to G, the arc, is 80. So F to G, the arc, is 80 degrees. And we're told that the angle GFH is 34. So we go G, F, H, that is 34. Now it tells you to find two specific things, and it tells you to find angle EGF. So you trace E, G, F. So it wants you to find this red angle, and then we want to find angle EFH. E, from here, go to F, go to H. But instead of staying focused on those two angles, I recommend you just ask yourself, what can you find and what can you do? For example, if you have this 80 here, you know you can at least find this, which is 80 from 180, that's at least 100. And then another thing you can find, if you have Post-its, you can frame this 34. So if you were to frame up the 34, you know that's an inscribed angle. Inscribed angle's half the arc, so if you have the angle, you just double it, and so this gets you 68. Now ask yourself what else you can find, and your ultimate goal is to find that red and that orange. Now if you know that 68, you can do this, and you can find that pink, and then look what the pink will find you. Once you have the pink, if you frame up the orange, which is one of the things you need to find, you can see you can frame this up and you can get the orange, because the orange grabs that pink. So just find everything you can and then find those two specific angles. Number 3, it says that RU and RS are tangent to the circle. Very important. RU and RS are tangent to the circle. That means you can do this. RU and RS touch the circle. I'd like you to trace RS and trace RT. First off, you should notice that RS and RT are arms of a tan-tan angle. That means they're congruent. So those two are congruent. Then we have this segment here, which is R to U. Let's see what other information we're given here. US passes through the circle center. RS is 9. So we just found from here to here is 9. And US is 4.8. So US is from here to here. And this is 4.8. Our goal is to find U to T, which is this tiny little pink thing. Okay, now don't panic. That seems like it's difficult. It's not. Let's look at what's really simple to find. We have a tangent here. We have a radius. Tangent, radius. Remember this? If tangent to a radius, radius, radius of tangent to a radius, right angle at the edge. So let's pull out and see what we have here. We have a triangle. This is 4.8. This is 9. And this, the orange, we don't know. But we can find it quite easily. Let's call it X. So we're going to do leg squared plus leg squared equals hypo squared. So leg squared plus leg squared equals hypo squared. So leg is 4.8 squared plus the other leg, which is 9 squared, equals our hypo, which is going to be X squared. You're going to solve for X. And once you find X, X is this orange piece. We know that the two reds are both 9. So once you find the orange here, and then you have the 9 there, final, you will find the pink by subtracting. Says right here, a rose garden is designed by joining a rectangle and a semicircle as shown below. The rectangle is 21 feet long. So that's 21 feet long. That's this part. That's 21. And that's 21 feet. And we're told that it's 13 feet wide. So from here to here, that's 13 feet. If the gardener wants to build a fence around the garden, how many feet of fencing are required? We're going to use 3.14 for pi. So our fence is going to go along the whole inside here. So let's just trace it. So let's look at the pieces of the fence that we already have. We already have the 21 and the 21. Do you see that? 21 feet. 21 feet. We even have the 13 here. The only part we don't have figured out is this. So we have to figure out how to find that. Now ask yourself what that is. This is half of a circle's circumference. It's half of a circumference. So we know circumference equals d pi. So for a half a circle, we're going to go for half of a circumference. We're going to go d pi over 2. That gets us the green. Once you have the green, you simply add up the 21, the 21, the 13, and that half circle. Number 5, it says a wheel on Dion's bicycle is 0.9 meters in diameter. So we have a wheel here, and the wheel is 0.9 in diameter. So we go like this, and we write D equals 0.9 meters. D equals 0.9 meters. Dean races the bicycle for 93 meters. So he's going to take and race the bicycle for 93 meters. The question is this. So there's the bicycle, and it's going to be turning. And it says, how many times does the wheel turn to travel that distance? So when you see the word turn, let's trace that word turn. Turn would look like this. We trace it. And you should see the word turn is actually code for circumference. So we need C equals D pi. That's our circumference equals our diameter, which is 0.9 times pi, and it tells us to use 3.14. That gets you your circumference. And then we want to ask ourselves, how many circumferences fit in 93? And that's a division problem. So you finish that yourself. Number 6, we have two semicircles are placed in a rectangle as shown below. The width of the rectangle is 7 feet. So let's look at what we're given here. We're told the width of the rectangle is 7 feet. That's 7 feet. We want to find the area of the shaded region. The shaded region is this region here. So it's that, this, and this. We're going to use 3.14 for pi. Do not round your answer. Now, to get the shaded region, you can see that it's called what's called a negative space. You have to find the area. There's actually two shapes here. There is a rectangle, and if you have the rectangle, and if you were to find the area of the whole rectangle, ask yourself, what would it take to get that yellow space? So if you look carefully, if I find the area of the whole rectangle, and I erase, notice I'm erasing right now. If I erase my half circles, then I'm going to have that shaded region. Do you see that? It would look like this, the shaded region. So how I do that to get the shaded region is I first find the area of the rectangle, and then I'm going to subtract the area of the two half circles. So I have to find this area, and I'm going to subtract the area of the two half circles. The only dimension I'm given is that 7 there. So you have to ask yourself, what else do you know? Now, if these are perfect circles, I'd like you to trace the 7 right there. Do you see that 7 is the same? Which is also right here. Which is also right there. So that is 7 feet. That's 7 feet. That's a radius of a circle. And if that's a 7, if we go this way, that's also 7 feet. So you need to use that information, find both the length and the width of the rectangle, the area of the semicircle, subtract, and get that shaded region. Says in the circle below it has a radius of 6 feet. So that's the first thing we're going to label, is the fact that this is 6, not feet, it's 6 yards. We are given that the angle of AOB, so AOB, is 60 degrees. We want to find the length of the arc ADB. So that's ADB. And we want to find the area of the shaded region, which is this. We're going to give the terms an exact pi. So watch it. We actually have 2 things we're finding here. We are finding the red, which is arc length, and we are finding the orange, which is sector area. So let's write our equations out. Arc length is a fraction of circumference. So we do the angle theta that we're working with times 360 times d pi. That's arc length. And sector area is a fraction of area. So it's theta over 360 times pi r squared. So now we go here. You have everything you need. I want everything in exact terms of pi. Now the only trick to this is, what is your theta? Careful. It is not 60. Your theta here in the shaded region is this angle right here, the pink angle. So your theta, your central angle you're working with, is the pink angle, not the angle 60. Use that, find your answers in exact terms of pi, watch your units. Number 8. It says a ladder leans against the side of the house. The angle of elevation is 70 degrees. So there's 70. When the bottom of the ladder is 16, so this is 16, find the length of the ladder. So let's pull this out. This is 16. We have a right angle. This is 70 degrees. And this is what we want right here, which is our x. This is a SOHCAHTOA problem. How do I know it? Because I have an angle and a side. So using this angle, we're going to label opposite, adjacent, and hypo. This is your opposite. This is your adjacent. And of course, this is your hypo. So you're going to do have, need, do. We have the adjacent. We need the hypo. I've got an AH combo. AH. So what goes with AH? Ka, which is cosine. So you write out cosine theta over 1 equals adjacent over hypo. You're going to use that, solve for x, round your answer to the nearest tenth.